Well, hello everyone, I'm Eduardo. Uh, and this talk is a little bit weird, okay? And I want to start saying that I don't actually hate containers or Docker or Kubernetes. So this is not a hate talk. This is actually more about the idea of needing versus wanting something, right? So there's nothing wrong with you wanting to have Docker on your small team or using Kubernetes to manage like 3 pods. That's fine, but you don't need it. And this is what this talk is about, what you actually need. And for people that are starting up, there are 2 talks from last year's PyCon that I really enjoyed and that motivated me to start this talk. The first one is from Katie McLaughlin called What's Deployment Anyway, from last year's DjangoCon. It's online, it's amazing. And then from Itamar, we had a talk last year called Zero to Production Ready, a best practice processes for Docker packaging. And this talk is a 50-minute talk on packaging a single application. And he had like 120 slides. And I thought, whoa, that's too much. For someone that's starting up, you don't actually need that. So I want to talk about when do you need containers, right? Because sometimes you do need them. And I want to talk when you don't need containers, which I believe is most of the time. What is expected from a production environment? I mean, why do we have a difference between development and production? And what is a web server and how to choose one? There are bunch of options for Django, and we're going to go through a few of them. What is a reverse proxy and why you should have one? And how to keep running everything all the time. And last but not least, if you're not doing Docker and Kubernetes, what deployment actually looks like for a production environment, right? So the main thing here is, when do you need containers? Well, I believe that you need containers when your company has programmers in the thousands, right? You are on one of those companies that are on hyperscale, hypergrowth. You are doubling your team size every 3 months, and things are chaos. And containers do help you manage those scenarios, that chaos. And you have users in the millions with unpredictable traffic. You have a huge spike out of nowhere, and you need to scale up really quickly. And last but not least, you have the valuation in the billions. So you can just pay for people exclusively to work on your infrastructure and Docker and Kubernetes and manage all of those things. But what about companies that have just a handful of programmers and maybe users in the thousands? So when don't you need containers? And my guess is pretty much the rest of the time. You actually don't need containers to run 99% of the projects out there, mainly because only 1% of companies are actually these hyperscale, hypergrowth companies. And there are lots of little companies doing just fine. So I want to do a little background on me and who I am. And I work for one of those small companies, and we have a SaaS platform that does digital advertising. It's called OnSign TV, and we have been running it for over 10 years. We have steady growth, profitability, but there's just 8 of us running the backend team. So we run our whole huge infrastructure on 7 virtual machines. It's like, do we really need containers for that case? Is that going to help us? But when you go online and search for this topic specifically, it feels like you should be ashamed of not using them, right? If you go on the Hacker News, you think like you are the dinosaur in the tar pit, just waiting for extinction to come for you, right? It's like, oh my God, I am not using Docker. I should just go and hide. And a lot of that is container FOMO, right? Your fear of missing out on something great. But it's important to understand that containers have a lot of things attached to it. It's not just one issue. So the advocates that they talk about containers, one of the things they talk about is reproducibility, right? So how are you going to write your code on your VM and deploy it to production, and you're going to have, if you're writing it on macOS and deploying it to Linux, you're going to have a bunch of issues regarding those two, the differences between those two OSs. But in my personal experience, in 10 years running on Scientific, that happened exactly once. We have a single issue that was caused by the fact that the file system on macOS is case insensitive, and the file system on Linux is case sensitive. That happened once in 10 years and was fixed in like 5 minutes. So do we really need this whole reproducibility argument to bring us down with a lot of complexity? And when we are writing Django code, we're writing code at such a high level that most of those differences will be ironed out by the platform. So Django will do a great job, Python will do a great job, we don't have to worry. But let's say you don't want to hear me, right? You want containers. So when you get containers, you get everything associated with it. This, I'm not sure if you can read it because it's tiny, tiny text. But the first thing written on top is overwhelmed. Don't worry, we have a guide. So they have, it's called the Cloud Native Landscape Initiative, and they have a map of everything related to containers and deploying and being cloud scale. And it's just huge. You can't possibly fathom one single person understanding all of that. And in an abstract way, we can think that containers is just a way to package your software so it can be executed. It's like compiling your code before you run it, but on a larger scale. But the thing is, once you have a container, you have to actually run it. And you build your image, you have to run it. And if you created a bunch of images of a bunch of different things, they need to talk to each other. So you will discover that you need orchestration, something like Kubernetes. And then you need so much more, like so much more. And I think that orchestration is a great thing, and we can get so much from it, something like zero-downtime deployment. But you notice that those things can be achievable on your own without having all that complexity, and those things won't protect you from yourself. Most of the downtimes we've had in the past were not caused by how we deploy the code. It was caused by someone not thinking that adding a column to a really big table will literally lock that table forever if the column has a default value. That is, if you're using Docker in Kubernetes or if you're deploying it yourself, the issue is the same. So I want to also talk about people with Kubernetes. They also talk about monitoring and the orchestrator keeping tabs on everything running. And mostly, things just work, right? If you create your software right, you won't expect a seg fault out of nowhere. And if you do, every single system that has ever existed has a process manager. You don't need something that has like 20 million lines of code to just manage processes. And so this talk is for the small teams. It's for people doing self-hosting. It's for people that are like doing it themselves. And the thing is, about self-hosting is nothing more than you get a real machine or you get a virtual machine that has an OS and you just use it. That's it. And there are a bunch of companies out there. They are called platforms as a service, such as Heroku or Elastic Beanstalk. And they provide things on top of those VMs. And in a way, Kubernetes was created to avoid vendor lock-in from those platforms. But you also have to understand that Kubernetes was created for hyperscale companies. And so they have much, much more than just avoiding vendor lock-in. And one thing that people usually don't talk about, and I do think it's unbelievable. I talked to a friend of mine that have a little startup in Brazil, and he was like, oh, it's great, everything is fine, but we are spending like $600,000 on AWS a month. And you're like, what's your revenue? Oh, we are like $100,000. We are running out of credit. And that's a real thing. That happens to companies that just outspend themselves by doing those integrations. And then when you have to fix that way later in your development, in your product lifecycle, you have already run out of cash. So we are talking about self-hosting not only as a way of understanding what you're doing, but also as a cost-saving mechanism. So what do we want in production that we don't want in development? And if you've been writing Django for any amount of time, you know about run server, right? It's the default way of running a Python application. And you think, okay, I'm running my code with run server, everything's working fine, and I gotta put it somewhere other people are gonna access it. Well, that environment is inherently different from your machine because the internet is the wild, wild west. And every single one is malicious. There's no good people on the internet. So in production, you need a secure environment. You need some protection against malicious clients. And you don't want to wake up in the middle of the night because someone crashed your site. And you also want to be able to fix things easily. So seamless updates are something really good for a production environment. So this is what you want. How can you achieve that? Well, the first thing you need is a web server. And there are a bunch of alternatives from the Django community. And a web server is something that will run your Python code. We are making that distinction here because we also have a piece of very important infrastructure that's called a web server sometimes, but we are talking about here as a reverse proxy. It's an HTTP server that will get all traffic from the web, sanitize it somewhat, and then forward it to our Django code. And we want a process monitor, a way of making sure that our application is running in case of reboots or in case of seg faults. And the last thing we want is a way to deploy our updates without much of a fuss. And you see, I think that one thing that it's important for everyone to understand is that scalability, it's a great issue to have. Most of the time, you won't need to be scalable. Most of the time, getting a bigger virtual machine is 100 times easier than getting 2 smaller ones. So that's just a fact of introducing on your platform things like different versions of your code running at the same time and dealing with all that complexity. So if you go the way of Kubernetes, you have those 2 for free. I mean, for free as in you already have Kubernetes, right? So, but you still need to choose the first 2 ones. And that's important because Kubernetes has the concept of an ingress controller, of something that will receive external HTTP traffic. And it's still up to you to configure that, right? So you're not getting it for free. And a web server is something that they just don't understand. They talk about a container, and a container exposing a port that will talk HTTP. So that's up to you. We're going to start with what we need, regardless of Kubernetes or not, and then we'll move on to everything else. So, choosing a web server. Like I said, you have your code, you're doing run server, it's working fine, you're going to push it to production, and then you check the run server documentation to understand which option should I turn on to run this in production. And you see this very nice warning where they literally scream at you that you should not use this in a production setting. It has not gone through security audits or performance tests. They don't care. Everything that's within parentheses, like those 4 lines, is just we don't care. So you have to choose it on your own. Python has Django has a great guide for that. But the guide doesn't actually help you choose. The guide just says what's available. So what should you choose? Well, it depends. And that's why the guide doesn't actually tell you something, right? So every site is its own unique snowflake. It's up to you, the developer, to understand what you're doing. But right now, you have, before you even think about web servers, you need to make a decision. You need to choose, are you going the WSGI way or the ASGI way? So the WSGI or the ASGI way. And we, as a community, have been evolving and developing ASGI for the past 5 years, and it is great, but there's always a but. And we're going to talk about it. So the WSGI is the standard way, right? It was created almost 20 years ago, even before Django. At the time, every single framework did its own thing, and there was no interoperability. The development landscape was really fragmented. And WSGI unified that and allowed a standard way of running Python web apps. And in those olden days, that was probably through mod WSGI in Apache, right? But that was 20 years ago, and the web has changed so much since then. I mean, we now have WebSockets. We make a lot of HTTP requests in our code ourselves because we're talking to external APIs all the time. So things have become more asynchronous by nature. And nothing of that is supported by WSGI. So about 5 years ago, we had a new protocol called ASGI. It's not still a standard, but I believe that Andrew, who is here in the conference, might be proposing a PEP one day, one can hope. And he created that based on the idea that we need a new protocol to support asynchronous things. And he started that by creating a project called Django Channels that was supposed to be the future of Django until it wasn't. Sorry about that. But that was a great exercise because many of those ideas are coming back to Django. So from Django 3.0, we got ASGI support. And we got in the latest beta, in the latest version, 4.1, we gained support for async queries and updates, which is amazing, but still no support for transactions, which is a bummer. So we still can't use everything we want in ASGI because it is, like I said, 5 years old. And we, as a community, which I love, we are slow people. And I just love that because I don't have time in my small team to update Python every 3 weeks, right? I need things to move at a slower pace. And the beautiful way of doing this is the way that Django is doing because you can mix and match as async and sync in your views if you're using ASGI. You do have to pay a small penalty for that. We're going to talk about it and we're going to see it. But you can mix and match them. And having said all that, I think that ASGI still has a long way to go. So it still is only 5 years, but it shows. And we're going to venture now in the land of WSGI, in the world of WSGI, starting with Gunicorn. Who here hasn't heard of Gunicorn? Okay, so we got what? Hi. So you're gonna hear a lot about it today. And Gunicorn is like hardcore old stuff, right? It comes from a time where you fork for each worker. It's like memory that doesn't exist. You just fork, fork, fork. And then the whole thing about forking once per every worker is that you have a great way of scaling if you scale your VM. And Gunicorn became the de facto way of running Django today. And like every old software, which is something that I love, it has so much flexibility, right? It has like 85 configuration settings. You don't have to use most of them. It also takes configurations from environment variables, framework settings, configuration file, an environment variable called Gunicorn command args that is just to simulate a command line argument and command line. And you can mix and match all those. Because this software, it has passed every single test there is for integration. And it's easy to integrate wherever you want. And one of the great things about it is you can have multiple worker classes, right? So a worker class in Gunicorn parlance is something that will actually serve your code. And in the old days, I'd say about 7 years ago, before ASGI, that meant that we had async workers that could hack into Python's code and monkey patch everything, so Python could just pretend to be async all the time. They called gringlets or green threads, and we don't do that anymore, thankfully. But still, Gunicorn is a great software. And let's talk a little bit about performance. And I'm going to say that performance is not important, but I'm going to show you why it's not important. So the thing is, the default worker of Gunicorn is called a sync worker. It processes a request, one request at a time. So there are no persistent connections. Every request will block the worker until it is complete. It is also really fast. So if you have, let's say this test we're doing here with 100 clients, right? You can get 50% of your requests delivered in 2 milliseconds, and the tail goes slightly up, and if you have 100% of your requests delivered in 4 milliseconds or less. That is just a plain request going through Django, working its way through the stack, and then being delivered to the client. Now, if you scale up the number of clients, you will start getting a little performance degradation, right? So, especially on the tail end, you can see here that most of your requests will be fine, will be under 6 milliseconds, but then things really tail up. And if you get 2,000 clients, that scaling up of the time it takes to answer 100% of your requests, well, that goes up, but you see that there's some linearity here, right? It doesn't scale linearly. It's more like a slow slope. None of the requests failed. It was able to answer 25,000 requests per second in a single 16-core VM. It had 33 workers. No request failed. We just had to wait a little bit longer. And that is using the sync worker class. And let me tell you something. That previous slide was the best case scenario, right? So you could not get faster than that. I'll publish the code later, but I have removed everything that I could from Django, and it was just replying to a single request. So why do we have that? Because you need to understand that performance is more about the architecture of your code than about the web server you choose. And the thing is, with the default sync, you are going to default sync worker from Gunicorn. The number of simultaneous requests is going to be limited by the number of workers because each worker can only answer one request at a time. And here comes the thing. If you do that, if your little Python code is connecting to an external API, then you are limited by that external API. You just brought that requirement right into your code. And until you get one of those replies, you cannot reply it yourself. So you're just blocked. And there's another thing here, that is, because every worker is its own distinct process, you will scale linearly with more workers in memory usage. For our product, it's about 200 megabytes per worker, usually, but there is a fixed cost that you're going to pay per workers. And so you can't really just think about adding more workers to overcome the limitation of only answering one request. And getting a huge VM with a bunch of CPU is not going to do you any good, because you're still fixed in how many requests you can take at once. But the great thing about Gunicorn is it's really easy to configure, right? You just need 3 configurations and you're good to go. And the first one, that is the W, is the number of workers. Then you put in your application, and then you just set the temp work directory, which is really important if you're running on a cloud environment. If you're not doing that today, please go and fix your code. And the last is the socket you want to bind to. And the worker temp directory is important because one of the ways that Gunicorn talks to itself to make sure that a worker is running is writing to a file. And if you're doing that on the cloud, that file is probably somewhere else. So you're doing a network request. Every request you have just to talk to the file system, it can lock things up. So, okay, that is the way of the Gunicorn. It is the old way. It exists. It has existed forever. But let's talk about the new stuff, right? So the new stuff, which is ASGI, you have Daphne. Daphne is the OG ASGI server. It was started in 2015, like I said, for Django channels, and it actually created the ASGI standard itself, and it was the first implementation. And Daphne is based on Twisted. Twisted here is for the old schools, because Twisted used to be all the rage in web development for Python in like 2003, 2004. Everyone was getting Twisted. And the thing is, Twisted is a great foundation for network development. It is async by default, so we're coming full circle of starting with async and then coming back to sync and then doing async again. And Daphne, it is one of the few frameworks that actually supports HTTP2 by itself. So you don't have to configure something else to have HTTP2 support. It's still in active development. It released version 4.1 like 10 days ago, I believe. It's like less than 2 weeks ago. And the thing is, it's a great piece of software, but it's also 5 years old. So it doesn't have a lot of knobs in terms of what you can configure. And sometimes you do need those knobs. Now, there's a new contender on the ASGI space. It's called Uvicorn. And I love those names. Like, love, love, love. So Uvicorn is a fast ASGI server. It has a focus on speed. How much faster than Daphne? Around 40%. And it uses a different loop called UV loop. It's a looping a signaling, eventing loop implementation. And that's why it's called Uvicorn. And one of the most important things about it is that it has a way to limit concurrency. Because remember on the first part where we talked about ASGI and we talked about how WSGI actually has a limit based on the number of workers you have, of how many requests you can answer at a single time? Well, ASGI doesn't have that limit, but you are still limited with how much memory you have. You're still limited in what machine is running your code, right? So having a way of limiting concurrency is really great, because you don't let things balloon out of control. And the last thing about it that it's kind of curious, and you're going to see in a couple of other topics, is that it can be run under Gunicorn as a worker. So Gunicorn is like Emacs. It can do everything, right? You can start your own web browser on it. And so how are we going to take a quick look on Gunicorn? And you see its performance is pretty much the same as Gunicorn. Things start scaling up a bit as the number of clients progresses. So still no errors, but you get a huge latency spike when you have more than it can handle. And that is based on a bunch of reasons, but it's also not very important, and I'm going to tell you why. So, because that scenario on that previous slide is different from Gunicorn. That is the worst case scenario for Uvicorn. It is not doing anything async, so you're just paying the penalty. You're not actually using it for anything. So it can only get better. From Gunicorn can only get worse. So it's very important to understand that distinction. And the thing is, we don't have a maximum number of requests that we can handle with ASGI. You can set it, but you don't have to. And by doing that, you also bring in another problem, that memory usage is less predictable. Memory usage can balloon out of control if you don't take that down. And how can you take that down? Well, you can take that down by using a reverse proxy. A reverse proxy is also something that can limit the number of concurrent requests to your backend. And you just, all of those servers we talked about here today, from Daphne to Uvicorn to Gunicorn, they all recommend having a reverse proxy. And a reverse proxy can also do SSL termination, which is adding SSL support, HTTPS support for your website. And one thing that always makes me happy is that things like a reverse proxy, they are updated really slowly with new features and really fast with security issues. And Nginx, if there's a security issue on SSL, it was discovered on Nginx, right? So it's what everyone uses. So one thing that it's important to understand regarding a reverse proxy is that not only serves your code, it also serves static files. And static files is something that has changed a lot over the past few years, mostly because of HTTP2 and JavaScript modules. And 7 years ago, I would be standing here and saying, you should bundle all your JavaScript in a single file. You should bundle all your CSS in a single file. Not anymore. That it's no longer required for you to have a good performance. But you should set expire headers far in the future to catch it. And you should use manifest static files storage, because that is one thing that will keep your site working. Every time you change a line in your JavaScript, when you do a collect static command, Django will actually calculate the hash of the file and append the hash to the name of the file. And this means that you can serve those files with an expire far in the future, like 1 year. And you won't be having any bugs relating to a client using an old version of your CSS or an old version of your JavaScript. It's great, and you guys should use it. So now we talk about Nginx, which is the ruling reverse proxy. It is the most used and most recommended of all of them. It is also incredibly fast. It is as fast as to not be a part of your thought process when choosing something, right? Because I really try to find a way of hammering it down and thinking, oh, it's gonna use a lot of resources. So I could saturate a 10 gigabit network link with an 8-core VM, and I still had 55% of CPU left. So it is a non-issue. That's why you should have it. It is really, you can get 20 million requests per minute on an 8-core VM serving static files. It's ridiculous. That's why people like Netflix still use Nginx. So the thing about Nginx is it is kind of hard to configure. Right? It is arcane. Its syntax was written by someone without, I don't know, a degree in language and language design. So it is kind of complex, and it doesn't do things that we consider table stakes today, like HTTPS. So here is a sample configuration of Nginx, and this is just to serve static files and then to forward it to Gunicorn or Uvicorn. Well, it's actually, there's a little bit more. It didn't fit in a single slide. And today we have newer alternatives that are easier. Let me just compare that to this whole configuration, which offers HTTPS support for Caddy. Caddy is HTTPS out of the box. It has great default values, and you can literally configure it to be a reverse proxy in 5 lines. It can't get simpler than that. I mean, there's nothing there that you can remove because it's all there. So if you're starting today, maybe give Caddy a go. Don't sleep on it just because everyone uses Nginx. Like I said, Caddy is plenty fast for you, and it's much, much easier to configure. So now we're going to talk about keeping everything running all the time. And keeping everything running, here, there used to be a lot of motion in this area 10 years ago. You had a lot of process managers. You had from native ones from the system, like System vNet or Upstart. Then you had Supervisor D and a bunch of other monitors. But they all converged to a single one called Systemd. Systemd is really complex and looks scary. And I guess the best thing about Systemd is that everyone uses it. So it's really easy to find good examples, really easy to find good tutorials, really easy to find good documentation, because once it's everywhere, then you don't have a lot you have nowhere to run. And with Systemd, this is pretty much a complete example. So all you have to really do is you have to set what is going to run with this exact start line, which is actually your Gunicorn process, and then a way to reload it. And this is what's really interesting. Because if you do everything right, by the time we're done, you're going to be able to reload without losing a single request. It's going to be easy and it's going to be free, as long as you line all your ducks in a row. And so like I said, how are you going to deploy your code doing all that? Well, if you're using Docker, you're going to build an image and upload it to an image archive, and then you will deploy it, Kubernetes will deploy it, and will just rotate every single instance of that image to a different container. If you're doing it yourself, my recommended way would be to git deploy code. How many people here have done this in the past? Git deploy code is not hard to do at all. It is quite easy. So when you're doing git deploy, if you can SSH to a VM, you can git deploy to it. Simple. What are the permission models? Do I need an IAM account? No. You actually need an SSH key, and if you can go, you can actually deploy to it. This is, I'm sorry? Oh, there you go. Before you deploy to a VM, you actually need to configure 2 things on your Git branch on that VM. The first one is you need to set deny current branch to false, because you're deploying to what's already there, and Git by default denies it. So you're setting it to false, but git config deny current branch false. And then you need to put a hook. And that hook is going to call a script that will actually do the deploying for you. And you think, oh my God, now I have to write a script. I didn't want to write a script. So I'm going back to Docker. Well, Docker file is a script, right? So if you do one, you can do another. It's not that different. And it doesn't have to be really complex. You just override the files, install dependencies, collect your static files, reload your code, and that's it. So how does that look like? Well, it looks like this. This is a complete example. So you activate your environment, you enter your folder, you install your requirements, you migrate your database, you collect your static files, and you reload your Gunicorn. If you did everything that I set up to now, if you did a manifest static storage for your static files, and you used gUnicorn, and you used systemd, which is controlled by the systemctl command right there, if you did all that, you got zero downtime deployments for free. Like I said, the same kind of free that you're actually going to get with Docker, because most of the time the downtime is going to be on your code. Trust me, I've seen that. So let's wrap things up. And in conclusion, what I want you to take away from this talk, okay? The thing I wanted to talk about is don't be afraid of doing things yourself, right? You can choose the tools that work for you. And if you're a small team, you should prefer a stable technology stack. If something has an LTS version, is a great signal that that software is for real. If you're doing a new version every 6 months and completely changing your API, a small team doesn't have time for that. And last but not least, performance is less important than architecture. When deciding between WSGI or ASGI, it's more important to look at your own code and see, are you going to do a lot of requests? Are you going to do a lot of async code? Then use ASGI. And don't feel ashamed of just using WSGI. I mean, at OnSign TV, all our screens are connected to our service. We have over 50,000 simultaneous WebSockets connections, and we use Go for that. Did I offend anyone? I'm sorry if we don't use Python for that. So don't be afraid of mix and matching what you get, because the end result is what matters. Thank you very much.